Hi, everyone. This is Moore McCormick with BluEdge. We're just going to give it another minute or two. All the participants are joining are on mute. We're just waiting for a couple more people, and then we'll get rolling here. As we go through the presentation, if you have questions, you can go ahead and submit them through the chat window in the HD meeting, and our presenter, Arthur Young-Spivey, will address those at the end of the presentation. Thank you.
All right, good afternoon, everyone, and thanks again for joining the call. My name is Peter Rowland. I'm the Director of Technology Sales here at BluEdge. This webinar is being offered as a part of our BluEd, which is our technology-related educational initiative. Please note, in addition to this free webinar, we'll also offer much more in-depth educational workshops, seminars, lunch and learns, AIA-accredited presentations, and much more. So please visit bluedge.com and select BluEd courses for more updates. The next workshop is actually a much deeper dive into Rhino, which will be a 3-hour course conducted on site here at our Manhattan location, which will be April 19th from 4 p.m. to 7 p.m. Today's webinar will be conducted by our own BluEd subject matter expert, Arthur Young-Spivey. Please note, we will also be recording this session, and we will make this recording available for everyone. Currently, everyone is on mute, but we can have the questions in the chat window addressed at the end, and we could also open up for more questions at the end if time allows. So please feel free to type the questions in at any time, and thank you very much. Arthur?
Good afternoon, everyone. This is Arthur, and thank you for joining the webinar today. We definitely hope to inform you as much as we know about the additive manufacturing and 3D printing technology. So just a brief sort of understanding of BluEdge and just who we are as a technology company. We've been around for over 118 years doing blueprinting for clients, and it's been a very exciting time, as of late with the whole technological revolution, working with different types of 3D printing and 3D scanning and virtual reality. So we're definitely in a transition period, and with the digital technology, across the board, it's definitely being used in a wide range of different industries. So again, today's webinar really is going to focus on just talking about creating 3D models, how do they go to the machines. There are different types of technology to work with, and this definitely creates a world of just understanding that we hope to help everyone understand by the time we're done today. From a technological standpoint, BluEdge is definitely focused on a wide range of, again, different technologies, virtual reality, hyperlinking, 3D scanning, which is really nice because that gives you as built, and we give you back the data in whatever 3D software you're working in. Managed print services and color graphics. So kind of, you know, when we talk about the digital technology, we talk about 3D printing specifically and additive manufacturing, I kind of wanted to do both a view from 30,000 feet, but then also really getting down to the micron level. And I say micron because it's actually, the technology has the ability to print, you know, layer resolutions in the micron level. And how that begins to translate to models that are being created with the technology means that you're getting a better resolution. I don't want anyone to think about, oh, we can print just a model that thin and it'd be great. It's definitely not that. As Peter mentioned earlier, if you have any questions, please feel free to type them in the chat window. We'll leave, you know, enough room at the end to address any questions that people have specifically. When we talk about sort of just the 30,000 feet overview of just the different technologies and what they're capable of, what I kind of started to strategize in how we would put this together is, how do we think about making models that are going to be physically output to whatever technology? And what are those stages in process from whatever 3D software? Because pretty much any 3D software can go to a 3D printer. But today we're just going to focus mainly on the ones that we see the most of, which are Rhino, Revit, and SketchUp. But that's not to say that we don't see models from every 3D application out there. And they can all, again, go to the additive manufacturing, you know, machines. The first question that we always ask you as the client is what do you want the model to be? What do you want it to do? When we start to flesh out these questions and these answers, it starts to become, you know, is it for a client presentation? Is it for an actual like physical engineering model that you need to do structural testing on? Once we start to get an understanding of where you want to go with the model, that really then helps us begin to understand how to begin to parse through the data that you guys are giving us to create. There definitely are times when we will actually mix and match technology. So it's not just about, you know, just print and go. It's always generally a discussion, I think, just like you do with your current processes on a daily basis. So, and I bring up this slide because this is great. It's like we were at opposite ends of the scales not more than 10 years ago. And I say this in that 2D, you know, drawings were prevalent everywhere. And when the additive manufacturing 3D printing technology has been around for over 30 years, being able to send something to a 3D printer, we need a 3D model. So it became this question of, well, how do we generate 3D models that we can send to the 3D printer? Today, we're at the other end of the scale where we have construction document level models, and we definitely have too much information, right? We don't need all of the studs, or we don't need all of the wiring. We don't need all of the HVAC. So sometimes it really is again a question of like what details do you want to show, and sometimes we may actually have to exaggerate those details, the mullions, the facades. You know, we have to either exaggerate, like change the scale. And I know that's one of the things that, you know, most architects don't want to hear is like we're changing the scale. But if you think of it from the standpoint of you've built your model at a 1-to-1 scale in the computer, and then you scale it down to whatever machine, it's going to be very, very thin. And that's the sort of part to this equation that the software from that side of it has to begin to give some feedback. And currently right now, really that's just us speaking with you about your project, about your models. When we start to look, again, in stages of process, you've built your model in the computer at, 1-to-1 scale. So it becomes a question of, well, what scale do you want it to be? Once you choose a scale, then at that point, it becomes about what is too thin. And I put this in there as, you know, there's no such thing as too thin, kind of as a thing because it's always a question that we're asked, how thin can you go? It's a very subjective response because I can't say de facto all the time, if you go to this thinness, it'll always work. Because if it's a piece of geometry that's connected to a wall, it's very different than if it's a piece of geometry just floating out, kind of out there by itself. So generally, once you choose the scale, we scale the model down, and then we begin to kind of figure out, well, what's going to appear in what technology. So once the scale is chosen, then you start taking measurements. And when you exaggerate some of the details that come up, sometimes people say, well, you know, I think the railing or the banister or the staircase, you know, that just doesn't look right. But if it can print and you can show it to the client, that's what we're, I think, in the end looking to do or looking to help with. Materials. You could definitely do just a presentation just on the amount of materials that are available with the additive manufacturing technologies, right? You have, you know, chocolate, you have concrete, you have metals, you have a whole range of different possibilities. And they're getting better and better all the time. I think that's the one thing that we've seen more than anything else. We've seen wood 3D printers. We've seen carbon fiber 3D printers. There's glass 3D printers. So from that standpoint, the availability of materials that are available today just weren't even around, in some cases, 5 years ago or even 2 years ago. So these materials are always changing. In general, though, most of the technologies that are around are really only doing one material at a time. There are definitely exceptions to this rule where certain technologies are actually doing multiple materials at the same time, which is really amazing that you can get, for example, a plastic part with the rubber overmolded detail to it, or if you have a clear translucent material, you can have that in different colors or in so on and so forth. So materials play now just as much a part as that first initial stage as the scale. Because again, once you scale it down and then you make your measurements, you're measuring it to the material that it's going to be made in. Once you have all of this kind of like, and those first three stages, if I go back for just one brief moment, the first stage, the scale, the measuring, and the materials, we go back and forth. It's never just like one click and go. It's always a discussion that in the end, you want to be able to export the model. Exporting the model to the different software, if you will, the print drivers for the different machines are getting better and better in that they're able to now, in some cases, start to take your native file formats. That is to say, if you're working in ArchiCAD, or if you're working in Vectorworks, if you're working in SketchUp, you're able to now, in some cases, open up the native file. If not, at the very least, the industry standard has been STL, which for the most part is basically taking your geometry and triangulating it into a mesh. Just know that the STL file specifically as a format does not carry across color or textures. It's just a monochromatic sort of a file format. The formats that do carry colors, as you can see, textures. So if you do a wind analysis, or if you do a lot of residential work, if you do a stress analysis, all of those colors can translate onto the actual model that you're printing at the same time. A few things that will definitely show when we open up the 3D software today that I'd like to demonstrate, that if you make a great model from the beginning, you can definitely achieve, a model that's going to go right to the machine. These are some of the things that the machines care about. And this is not to get too technical or anything like that, but these are just terminologies that are used when it comes to this, the way the machine understands the models. So the first thing is just the normals. Some of you may be familiar with this if you do a lot of renderings, and then the naked edges. So as an example, when we look at apologies. We look at the normal direction. So what basically we're talking about is this is a thin piece of geometry. It has no thickness. So because it has a second side or on another side, that is important that all of them are facing the same direction. And again, we'll show this when we actually open up the 3D software. But being able to flip the direction that the normals are facing is very important when you're exporting out the models for 3D printing. The second thing to always consider is, are your edges welded together? If they're welded together, that means it's watertight, and that makes it 100% 3D printable. I'm showing an example here of what they call like naked edges, and depending upon your 3D software, you do have some aspects to be able to fix this geometry. So this is really kind of the heart and soul of it all, right? Is that when you're making a 3D model, the model that you make for, in this case, for renderings, is not the same model that you use for construction document. Conversely, the same model that you need for construction document and for rendering is not the same that you need for 3D printing. And eventually, the software, might get to the point where it will be able to start with one model that can go to all three. But until such time, you definitely have to take into consideration what direction you're going to go in at that specific time. When we start to look at being able to visually see on the screen, so here's an example in SketchUp, where if you're just drawing a cube, generally all the faces are going to be white in color. But if you're seeing the other side of the face, the native color is like this blue kind of grayish like color, and it's sometimes hard to distinguish. So one of the things we recommend is that you can go here into SketchUp, for example, and you can go into the styles, and then you can change the actual color of the back face. And I chose purple, but by all means choose whatever your favorite color is at that particular point in time. Revit. For those of you using Revit in your workflow, you know Revit is a really powerful program. But one of the things that it kind of lacks, at least at this current point in time, is the ability to really check the file for any bad geometry. That isn't to say, though, in general, because you're generally working with solids in Revit, you're pretty much going to have great models to begin with. But it's being able to parse out the layers or the families that you don't want to be printing. So that's kind of the other side of it. So one of the things that we recommend is we kind of like use Rhino in this case to kind of back us up, if you will, in that we can export out DWG from Revit, and that leaves it as surfaces, not a mesh. Because working with mesh geometry just in general can be pretty taxing on some of the software, depending on what you're using. So keeping it as a DWG keeps it as what we call NURBS geometry. And this is the last slide, and then we'll start to jump into the 3D software. These are some tools that I would recommend. If you're specifically like in SketchUp, the solid inspector, that's what you can use to interrogate the model to see if it's good for printing. And it will do some baseline repairs. MeshLab is an open source software that you can actually use. It's definitely a little bit more complicated, but it can do some mesh editing and repairs as well. And then you have like paid software like NetFab from Autodesk that really has some very robust tools for fixing files. With that said, we're going to jump out and jump into some 3D software. So here we are in SketchUp, and just again trying to just reiterate some of the things that we talked about during the presentation, which is this. You can see how this side of the face is white and that other color, the flip, is purple. So if we were to select that and just pull this up, you can see that you can select this face. So if I click on where it says reverse face, you can see how like that color really stands out versus the initial like gray color. And again, this is where you can change it in the style to a different color. The reason why this is important is that when you're saving out again, in this case, we'll just say with sticking with STL, the STL, you got to think of your model as like a magnet, right? If you think of your model like a magnet, then the shrink wrapping or the STL is going to shrink up your model with a bunch of triangles. So all of the faces that are facing inwards, or they're going to attract the geometry. They're going to attract the triangles. If it's flipped, it's going to repair it. It's going to repel it. Sorry. So in that specific instance, this face is not going to print. And if you can imagine, if that face isn't printing, then it's going to print this hollow shell that has no wall thickness, and it's not going to be able to print at all, no matter what machine you have, right? So in this specific instance, being able to right mouse button click and just say reverse faces helps, just clean up that model, right? The solid inspection tool, you'll see this little icon here. Again, you can get this from the SketchUp warehouse, extensions warehouse. So when you get it from there, you're able to, for example, click on this, and it brings up a little dialog box. And it says, hey, you have reverse faces. It'll try to fix, and it says, everything is nice and shiny, we're good to go. Now, again, I can definitely say that I wouldn't call this a magic bullet. It's not going to fix all of the models, especially like if you download something from SketchUp Warehouse and try and just go to print that. Again, some of the initial rules that we talked about before, scale, materials, measurement of details. Those are all really important, not just this aspect, but I just wanted to show you guys, this is a free plugin for SketchUp, right? Okay, so with the same sort of thought process we talked about before, so now I have a bunch of boxes, and you can really see a difference with how, just on the screen, like this box is completely flipped inside out. That would not print, right? And if you're working in again, whatever software, specifically in SketchUp, you're talking about being able to group geometry or make components of geometry. And that can definitely make a difference in terms of the type of output when you go to export the geometry. So when I select this is all one group. And if I select this geometry, you can see that this is grouped together as two pieces, or it could also be considered a component. If you export this as such, they're going to export as a group. They're going to be linked in the same file, and that may or may not be your intended result. So that's something that you definitely want to go in and you can go into the edit menu and you can explode it. You should explode it so that it can actually see the different components. All right. There are definitely times when you might want to print pieces as one piece. So that's why we might use the option to group. But if we use that same tool here that I showed earlier, the inspection tool, you'll see that, again, it brings up a nice dialog box that says, hey, well, there are two nested instances. There's 6 reverse faces. So you can fix that. You see it fixes that box that was inside out. And all it's giving you right now is not that there's anything wrong with this being nested. It's just giving you kind of a heads up more than anything else. In terms of being able to export out models from SketchUp, you definitely need SketchUp Pro to get more of some of the advanced sort of, or I would say more universal neutral formats, right? So FBX, IFC, VRL, OBJ, like some of these formats are available, but some are not. You need SketchUp Pro for them. One thing I will say is this: if you do have SketchUp and Revit at the same time in your workflow, being able to use the IFC file format is definitely what I would recommend if you plan on exporting your model from SketchUp and bringing it into Revit. Okay. And being able to add textures or things like that, that's definitely more for the in-depth course, but just know that you can export a model from SketchUp with the textures. Again, if it's a brick, if it's wood, what have you, if it's on the model, that can export and go to the 3D printers directly. We definitely see that a lot more with residential clients rather than commercial, but just know that that is an option. Okay, so we jump out of SketchUp and let's go into Rhino. And Rhino is definitely it's great. It works both for Mac and PC, just like SketchUp. In terms of making geometry, it has a plugin that some of you may or may not be familiar with called Grasshopper, which has been very interesting for some of the facades that you're seeing for being generative in terms of the nature of how you create geometry. But for now, we're just going to really just talk about, again, some of the same settings that we showed before, but you can see it here live. So specifically, I'm going into the options for Rhino. And initially, when you install, it's going to say that your back faces are going to use the same color as your front. And this is something I absolutely recommend 10,000%, which is that you can say single color for all back faces. And here I'm using that same purple color. I don't know if I'm having a Prince moment, but it's you can have it be whatever color you choose. Again, what this is giving you is direct on-screen notification of what's happening with your model. So with that setting change, again, you're finding under the view, under display mode, under shaded. This is where you find this option for a single color for all back faces. So if we go and make a box, and we'll switch our view, we'll switch it to being into shaded mode. If we take the box and explode it apart, in Rhino, you can very just easily, you can type your commands as if you usually know that, you can just type in flip, and you can immediately see there's that same purple face that we saw in the example in SketchUp, right? Again, if your settings are the default, you'll see it's the same color, and that's not giving you that same indication, direct on-screen feedback. You can select any poly surface, and there's a tool over here on the left side that analyzes the direction. So if you click on that, you'll see that the white arrows are actually showing you what direction that face is actually going in, right? So if I do that same command over here, you'll see that they're facing outwards. So in general, you want all your faces always facing the right direction. So one of the nice things about Rhino is that if you select the whole thing, and if it can make a watertight geometry, if I join that together, actually, I'm going to undo for one moment and just turn back on the options for the back face. So we pick this whole thing and join it together. You'll notice that it automatically flipped that face to the inside. So that's a nice feature just built right within the Rhino tools to go and edit and change the geometry. So if we explode that, if I hit delete on the keyboard, you get that same empty shell on the inside. The one thing I could say across the board is this: the machine makes what it sees, right? So if you have a window and your window is only made of one surface and there's no thickness, it's not going to print. And that's just something that we definitely understand. Like, it's easier to just represent sometimes geometry with just a surface, but at the very least, you can type in, offset surface, and when you offset the surface, it's giving you a direction of what side it's going to go to. So you can always flip which direction and give it a value, and then this now has some weight. This is watertight geometry that is printable. Okay, so again, just doing a brief overview, and then we'll check out the questions, see if anyone has any questions. We're going to bring up Revit, and just opening a file here. Again, Revit doesn't have any native tools really built inside of it to handle fixing geometry, but again, because you're working in many cases with solids in Revit, you don't really have to worry as much about necessarily flipped normals or naked edges as much as you have to worry about how much information do you want to show, right? Again, a lot of that goes into what scale you're printing at. So the discussion of, the legs for this table, right? It's like on the model, when we print this out, are they going to be too thin when you scale it down to the machine? And if so, in many cases, we may just, just traditional model making at that point. We'll just make the table with, balsa wood or chip, or we'll laser. We'll do anything to achieve the result of that model. But again, sometimes it doesn't make sense to print it out, either because of detail, or there may be support. Right? There's generally always some type of post-processing that needs to happen once it comes out of the machine. So there's supports that may happen under here that we may not be able to get to, or might not be able to dissolve away as cleanly. So we may print this separately and then just drop it in afterwards, right? So these are, again, always discussions. And in general, when you send the file to us and if we're going to print it for you, the production team is always looking at the model. And if there's something that's a little skewed, we will definitely call you and do a go-to meeting. And go from there. So again, to just show very quickly, export this out as a DWG file. This is probably the most important aspect about the DWG format so that you can keep it as, again, NURBS or just surfaces. You have to click on these little 3 dots right here, which then gives you this option. There's this middle panel right here that says solids. When you click on that, the default export for the DWG is as a polymesh, which is not, again, working with mesh geometry is a little bit more challenging. So if we just say as a solid, that will then make the model much easier to work with when we're bringing it, if you want to work with it in software like Rhino or something like that. So we'll just go ahead and save this model. Again, just want to show you guys the whole process from start to finish of exporting the model and then bringing it into Rhino, and again, some of the tools that we may use. So if we go and open this model, what's going to be very important is that you're opening it in the same units that you're working in whatever software you're working with. But being able to just bring it into Rhino, you can immediately see you're getting one-to-one. If we go into the shaded mode, you'll see that these are actually surface geometries. These are poly surfaces, just in general. So at this point, one of the easiest things to do that we love in being able to say, use a bounding box. So use a bounding box, you pick everything, it puts a box around your whole model. And then we can begin to start to talk about scale. We can scale it down and kind of go from there. Layers, we can then begin to put the doors, we can put the furniture, we can put things on a different layers. If you want to do, because you notice that it's carrying across the colors that you're seeing in Revit. So if we go to a new layer, we'll call it 3D printing. I'm going to just select everything and choose this option to copy objects to layers. So everything that's selected is going to be copied to this new layer, which we then make active, and will then hide all of the other layers. The reason for doing this is, if you remember, one of the things we immediately want to check to see is, well, are there any inverted normals or naked edges, right? So if in this geometry we explode this apart, you see there's no purple, unless I would like specifically type that in the geometry. So again, you're generally 90% of the time you're going to get great models coming out of Revit. In Rhino, you can just type in the command. It's called show edges, and again, we're picking everything, and this edge analysis tool is basically saying these are initially it's going to say all edges, and that's not what you're looking for. You're looking for the naked edges, and if you see any purple, much like you're seeing here in all edges, then you know that that's something you have to begin to address. So we have a couple of things. We have definitely wanted to get to your questions. Let's see if we have.
It's on your screen.
Hmm?
The chat's on your screen.
Yeah, I'm looking.
Get back to me.
Just one second. We're just trying to get to the
And then I waved my finger over like I was filling it in. I wasn't actually.
Hello. So it looks like our chat window is was disabled. So if anyone wants to maybe ask any questions initially, we can begin to address them. So everyone is unmuted.
Questions?
Hello, does anyone have any questions?
So your customers are asking if the computer that's doing that.
I'm not sure if you guys were able to hear before, but if anyone has any questions that they'd like to ask specifically about the 3D printing process or file formats, let us know.
So again, thank everyone. I just want to thank everybody for attending. We have a much deeper dive into, as I mentioned in the beginning of the webinar, into Rhino. It's a full 3-hour workshop, much more related to the functionality of Rhino, not just as it relates to 3D printing, but in general. So what we're going to offer, whoever attends this course, or this webinar rather, we'll send a direct communication to. You'll have a discount available for the upcoming Rhino workshop. And again, if you just want to keep that in your calendars and continue to check our BluEdge courses section of our website we have SketchUp courses as well, AIA accredited presentations regarding virtual reality, 3D printing. We can do lunch and learns on site at your locations as well. So thank you again very much. And if there are no questions, we'll go ahead and end.
Great, thanks, Arthur. That was terrific.
Thank you. All right, everyone have a good day.